Sugar restriction actually causes a bigger decline in blood pressure than salt restriction does. Sugar's a bad guy in the story, full stop.
So what, Robert, is wrong with our diet?
Number one, what everyone thinks is wrong with our diet is not even remotely what's wrong with our diet. Every country that has adopted the Western diet is now sick. And that goes around the world. And there are countries that are actually more diabetic than we are, and they're not even fat, like, for instance, India, Pakistan, and China. Now, they think, well, they're not fat, so there's nothing wrong with their diet because, after all, it's the Western diet just causes obesity. No, obesity is just a marker for the problem. It's not the problem itself. In fact, 20% of obese people are metabolically healthy. They will live a normal life, die at a normal age, not cost the taxpayer a dime. We have a name for these patients, MHO, metabolically healthy obese. They will outlive you and me. Okay. They're just fat. They have increased subcutaneous fat. Well, that subcutaneous fat is protective, not detrimental. Okay. Yeah. That's a good thing to have, not a bad thing to have. Yes, some people have more than others. On the other hand, there are plenty of thin people who are sick. And the reason they're sick is because they have fat where they didn't know they had fat. Like, for instance, the viscera in terms of waist circumference,
organ fat,
and most importantly, liver fat. And we've identified the liver as being the, sort of sentinel problem of this entire thing, liver fat. I was just at the Obesity Medicine Association meeting just this past weekend, explaining why fatty liver is basically where the problem is. So the question is, why is it that we had never heard of fatty liver disease before 1980, and now 45% of adults and 25% of children, not obese adults, not obese children, all adults, all children, now have a disease that didn't even exist 50 years ago.
Yeah. I mean, except for alcoholics, they'd get fatty liver, right?
And that's the point. Only alcoholics had this. And now everyone has this. And children don't drink alcohol. But children consume something that is just like alcohol. And that is sugar. Sugar and alcohol are virtually identical as far as the liver is concerned. The big difference between sugar and alcohol is that for alcohol, the yeast does the first step of metabolism, which we call glycolysis, anaerobic glycolysis. For sugar, for fructose, the sweet molecule sugar, we do our own first step of metabolism. But after that, they're exactly the same. And so it makes sense that children would get the diseases of alcohol without alcohol. So until we fix this problem, and by the way, this is just one of several problems with the Western diet, until we fix this problem, nothing else is going to work. And I actually proved this in our own clinic here at UCSF. Because what we did was we took 43 children from our clinic who had metabolic syndrome. So
this was in the movie Fed Up, right? This explanation.
We had not gotten the results on this study back when Fed Up was recorded. This is actually newer. So it's not in there.
So there was something like that in the study where you put the kids in a metabolic ward and you fed them different diets and you saw what happened very quickly, right?
Right. Well, 10 days. What we did was we figured out what they were consuming on their home diet. Okay. We studied them on their home diet. Then for the next 9 days, we catered their meals. No added sugar. So we took the percent of calories from sugar from 28%, which is a lot, down to 10%. Yeah. Okay. Now, if you do that,
10% is still a lot.
Well, that was when we gave them fruit. So we gave them fruit. That was pretty much the only sweet thing we gave them.
Yeah. Yeah.
Now, if you do that, you're going to take 350 to 400 calories a day out of kids' diets. And if you do that, number one, they're going to be hungry. And number two, they're going to lose weight. We didn't want them to lose weight because, hey, if they lost weight and they got better, people say, well, of course they got better. They lost weight. We didn't want them to lose weight. We actually wanted them to gain weight. So we had to substitute the sugar with something else that was equicaloric. We gave them refined starch. So in the vernacular. We took the pastries out, we put the bagels in. We took the sweetened yogurt out, we put the baked potato chips in. We took the chicken teriyaki out, we put the turkey hot dogs in. Okay, so we didn't give them good food, we gave them crappy food. We gave them processed food. We gave them Safeway food. We gave them kid food. Food kids would eat, okay? But it was no added sugar food. And we also gave them a scale. And every day we'd call them up on the phone, what'd you weigh? And if they were losing weight, eat more in order to keep their weight constant through the 10 days. And then we studied them 10 days later, and lo and behold, no change in weight, but the fat in their liver went down 22%.
Wow.
Their conversion of sugar to fat went down 46%. Their triglycerides went down 49%, just 10 days. Their visceral fat, the belly fat, went down 7%. And most importantly, their insulin in their pancreas started being released and working properly. In other words, we reversed their metabolic syndrome with no change in calories and no change in weight. And what this told us was that it's not the weight, it's not the fat, it's the liver fat. And that's the fat you can't see. That's the fat you can't measure when you stand on a scale. And that's why we have metabolically healthy obese people who don't have liver fat, and we have very thin, sick people who do.
In my understanding, and this is, David Ludwig says this, below the neck, your body can't tell the difference between, cornflakes and a soda, right? Or between a bowl of sugar and a bagel. And I think, refined starches are also a problem. So what I don't want people to take away from this is that you can eat refined starches and that's okay. And I think it's still a problem.
Let me delve into that a little bit. Let me unpack that. Okay. Sugar, dietary sugar, the sweet stuff you put in your coffee, the crystals, is 2 molecules in one. Okay. It's called sucrose, but it is 2 molecules. One is called glucose. One is called fructose. Now, glucose is the energy of life. Every cell on the planet burns glucose for energy. Glucose is so important that if you don't consume it, your body makes it.
Yeah.
Okay. Makes it out of proteins. It makes it out of fats. So you will always have a serum glucose level. The Inuit, who basically didn't have any carbohydrate because they didn't have any fields to grow any carbohydrate, they ate whale blubber. They still had a serum glucose level because glucose is that important. But it's not important to eat because you can make it. Now, fructose, that sweet molecule in sugar, is a different animal entirely. Okay, there is no biochemical reaction in any vertebrate that requires dietary fructose. It is completely vestigial to all animal life. Now, it just so happens it's sweet. It just so happens we like it a lot. It just so happens it's addictive, but it is actually metabolized like fat, but it is completely unnecessary. Now, glucose will stimulate insulin release, and that's not good because insulin release will drive energy into fat cells and increase weight gain. And that's what David Ludwig is talking about. And he's right. And he's right. I'm not saying he's wrong. He's right. But fructose, because it gets stuck in the liver and causes that liver fat, you get insulin resistance. So 2 different phenomena, 2 different things. One's called insulin secretion, insulin release. The other one's called insulin resistance. They are not the same. Insulin release will cause weight gain. Insulin resistance will cause heart disease, diabetes, Alzheimer's, cancer, and virtually all of the other chronic metabolic diseases that are chewing through our entire healthcare system. Insulin resistance is the bad guy. Insulin secretion is basically what we're talking about when we're talking about the scale. Insulin resistance is what we're talking about in the doctor's office.
But eventually, though, if you have enough of the refined starches, even if you don't have refined sugars, you will see an increase in insulin resistance because you have to produce more and more insulin and the cells become resistant. So it's sort of related, but I get your point. Fructose really has a unique effect on the body. We had Richard Johnson on the podcast who talked a lot about the dangers of fructose, and David Perlmutter talked about this, what he called drop acid, meaning uric acid in this role, and as a real accelerator of insulin resistance. And
True.
and chronic illness. So I agree with you, Robert. And I think, it's so amazing to me that the single biggest driver of our exorbitant healthcare costs, of our declining health globally, of all of our chronic diseases, heart disease, cancer, diabetes, dementia, even depression, and more, are driven by insulin resistance. And yet it's something we learn almost nothing about in medical school. My daughter now is in second year medical school. I think she had like an hour on it. And it wasn't really in the context of what's really driving it. And it's like, if you treat that, you treat so many of these chronic illnesses. And it's one of the drivers of all aging. I just finished my book on longevity called Young Forever. And it basically, if you look at the science of this, the science of insulin resistance is really the science of chronic disease and the science of aging and the science of death.
Couldn't agree more. In fact, insulin resistance is the sentinel problem in all of these chronic metabolic diseases, because insulin resistance is a manifestation of mitochondrial dysfunction. Mitochondria are the little energy burning factories inside each of our cells. And when our mitochondria work efficiently, we are healthy and our blood glucoses do not vary very much and our weight stays stable and we feel good and we can sleep well and all is right with the world. And as soon as our mitochondria don't work well, all hell breaks loose and we get all of these chronic diseases and we feel like crap, et cetera, et cetera. And we end up having to take medicines in order to try to make our mitochondria work better, except guess what? We don't have a medicine to make our mitochondria work better, because no medicine can actually get to where the problem is. Okay.
But it's foodable, not druggable, right?
Right. So that's the whole point, is what's wrong with the mitochondria and how do you fix it? That's basically what this whole story is about. And to be honest with you, Mark, that's what functional medicine is about. Okay.
Yeah,
whether they taught you that or not, that's where we are.
No,
okay.
It's for
Fix
sure.
the friggin' mitochondria. All right. So
absolutely.
What's poisoning them? That's the big question in all of medicine. And
before we get into the I want to get deep into mitochondria and all this, but I just want to kind of back up a little bit, because we said a lot of stuff and I want to make sure people get it. So I want to talk about how we diagnose insulin resistance, and you have in your book a way to self-diagnose, because it's really important, because your doctors are missing 90% of it. They don't get taught how to diagnose it. They don't, because there's no simple drug for it. So if there's no drug for it, why test for it, right? And you just talked about a few major things that are a little bit confusing. One is you can be metabolically normal obese, meaning you're overweight but metabolically normal. And I think that's a small number of people. You can be metabolically obese and normal weight, like the people from India and China. They can be on their BMI, their body mass index, normal, but they're still diabetic, right? Right. And that's dangerous. In fact, I've seen some studies that may be more dangerous than being overweight and metabolically unhealthy. And then there's the obviously the overweight, the metabolically obese, and obese patients. So there's these different categories. Some of it's genetic, some of it's, has a lot of variations, but you kind of can't know until you test. So explain to us how we can understand what's going on in our bodies. How do we test for this phenomena that's driving all these diseases, for which we're taking so many medications that aren't really working? They're just managing the disease and they're not actually treating the problem, they're treating the symptoms.
Totally. The problem, of course, is that your doctor has access to all of this and you don't. And you need to, and they need to, but they don't understand it, which, maybe you can teach your doctor what to do. How would that be, all you audience out there? Okay.
I love that.
So, all right. Sometimes doctors are a little, shall we say, provincial, and they don't necessarily, listen to their patients, but they really should. If they listen to their patients, they'd be much better doctors. All right. Number one, you look at your waist. Now, your waist is a conglomeration of many things, but primarily visceral fat and liver fat. That's what determines your waist circumference. If you are a male and your waist is 40 inches or greater, the chances are you have visceral and or liver fat. And that probably means you have insulin resistance and you have mitochondrial dysfunction. If you are a female and your waist is 35 inches or greater, same thing. Now, that's the cheap way. Unfortunately, it's sensitive but not specific. So there are other things that can, cause you problems as well, like ascites and other things. But, we're not
pregnancy.
Pregnancy. Right? Yeah, pregnancy. Thank you. Yes. Okay. So, which of course is insulin resistance also, but that's for another day. Then you start getting into the lab tests. Okay. What lab tests do you need to get? The most important lab test for determining insulin resistance is a fasting insulin. Now, doctors don't draw fasting insulins. I think it's the single most important lab test to draw, but they don't draw it. Why don't they draw it? Because the American Diabetes Association told them not to draw it. Now, why is it that I'm saying that this is the most important test that you have to run, and the Diabetes Association is saying don't bother? How come we are so completely diametrically opposite? The answer is because I'm right and they're wrong. Now, here's why.
I agree. Actually, by the way, I've been measuring this test for 30 years. And it's just astounding to me how important it is and how nobody tests for it who's in the conventional medicine.
That's right. So here's why the ADA says don't draw it. 2 reasons, and they're both wrong and specious. Number 1, they say, well, lab tests around the country for fasting insulin are not standardized.
Yeah.
Now, that is true. That is true. I don't argue that. And the reason is because cheap insulin tests, do not distinguish between the insulin molecule and its precursor, the proinsulin molecule. Now, proinsulin is a prohormone, meaning it's before you get the active hormone. It's bigger, and the pancreas, the beta cells in the pancreas make this thing called proinsulin. And then there's an enzyme that cleaves the C-peptide piece off, and then you release the insulin. Now, when you're sick, when you're insulin resistant, your pancreas doesn't have time. Okay. And that may actually even be a problem, that you have a problem with that enzyme. And that enzyme is called PC1 or prohormone convertase 1.
Yeah.
Now, you may, if you're sick, release both. You may release both proinsulin and insulin. And so proinsulin gets picked up in the insulin assay. So indeed, insulin assays around the country are not standardized. So the American Diabetes Association is right about that. But so what? If it's high, you got a problem. Okay.
Exactly.
And they basically don't understand that. And that's specious issue number 1.
Yeah.
Specious issue number 2. They say insulin levels don't correlate with obesity. That is also true. They correlate with metabolic health.
Yes, and heart disease and cancer and dementia.
Exactly. Okay. And we just told you that there are thin, sick people. Okay. So they're not registering on the scale, but then they don't know that they're sick.
Yeah.
So this is exactly why we need to be drawing fasting insulins, is to figure that out.
Yeah.
So fasting insulin.
And by the way, the other thing I do, I would just say, it's going to add my 2 cents, because I've been doing this for a long time too. And I started measuring not just fasting insulin, but I measured a glucose tolerance test with insulin almost on every patient who I thought even smelled that they could have had metabolic syndrome. And it was fascinating to see the data on this. You'd see people with like blood sugars that were perfect. Like I had this one woman, like a big apple. Her fasting blood sugar was like 90 after the 75 gram glucose, which is like 2 Coca-Cola worth of sugar. Her blood sugar went to like 110, never even went into glucose intolerance. But her fasting insulin was like 50, and it went to like 200 at 1 and 2 hours. So I found that very helpful. And fasting insulin is probably the second stage the first stage is a postprandial insulin that goes up, right?
Yes, exactly right. So, in fact, we did oral glucose tolerance tests with simultaneous insulin levels on kids, published this back in the early 2000s, this is where we realized where we had these two problems. One's called insulin hypersecretion, and those kids are fat but healthy, and this thing called insulin resistance, and those kids were fat and sick. And so even though they are both insulin problems, they are for different reasons, and different things in our diet cause each of them. So, insulin hypersecretion can be genetic. Insulin resistance usually is not, but it's very, very liver fat specific and very much dietary fixable. So we learned quite a bit by doing that. I don't need to do that anymore. And actually, I'm retired anyway, so I'm not seeing patients. But the point is, I can figure out from the other lab tests what's going on. So I don't have to do glucose
me too. It's actually when I was in residency training, I had a pulmonologist who was one of my preceptors, and he taught us to read X-rays. And he goes, well, this is this is that, and then he goes, and this is the Aunt Millie sign. I'm like, well, what do you mean? What's the Aunt Millie sign? Well, it walks like Aunt Millie, it talks like Aunt Millie, it looks like Aunt Millie, so it must be Aunt Millie. It's basically, if you look at the pattern, it's a pattern recognition. And if you look at the types of cholesterol, if you look at uric acid, if you look at all these other phenomena, hormones, you can tell so much about what's going on. So besides the insulin fasting level, what else should people be measuring besides their waist and their fasting insulin?
Right. So the next thing down the list is their ALT. Alanine aminotransferase. Okay. Now, the problem with ALT is not
it's a liver test.
It's a liver test. It's a test that tests for fatty liver. Okay. It's again sensitive, not specific. But the problem with ALT is not the test. The problem with ALT is the interpretation.
Yeah.
Now, in 1976, when I entered medical school, the upper limit for ALT was 25. Today, you look at the lab slip, it's 40.
It's 50.
Or 50.
And sometimes 50. Yeah.
Yeah. So same test, but now double the upper limit of normal. How'd that happen? The answer is because everyone has fatty liver disease. That's why. Okay, the entire curve shifted to the right. And the way the lab determines normality is they do a whole bunch of tests on 10,000 or 100,000 people, okay, and they get the mean and they get two standard deviations and they draw a line at those and say, okay, that's the upper limit of normal. Well, if the entire curve shifted, guess what? The upper limit shifts, but that doesn't mean it's normal. It just means that the patient didn't know they had a problem.
Yeah. Well, it's sort of like if you're a Martian landing in America today, it would be normal to be overweight and obese because that's what Americans are. It doesn't mean it's optimal.
That's right. And so, in fact, an ALT upper limit is 25. If you're African American, an ALT upper limit is 20. So if you see an ALT above that, you got a problem. And you don't necessarily know why. And your doctor's looking at it and saying, well, your ALT is 30, it's below 40 or 50, then no problem. And so your doctor's missing it.
Yeah.
So that's the second test.
And those are cheap. These are cheap tests.
These are cheap tests. These are tests that are normally done on standard chem panels. Yeah. The next test is uric acid, as David Perlmutter and Rick Johnson, are espousing. Now, uric acid is the breakdown product of purines. So if you eat a lot of meat, you will get a higher uric acid. It's true. All right. And of course, everybody with gout knows this. Benjamin Franklin knew this. Okay. He wrote an ode to his gout many years ago. But it turns out sugar also increases uric acid. Now, how can red meat cause increased uric acid and sugar increase uric acid? Red meat and sugar don't look alike. Well, in fact, in the liver, they do. And the reason is because they both cause an increase in ATP being converted to ADP, ATP adenosine triphosphate being converted to ADP adenosine diphosphate, which then goes down the breakdown pathway to uric acid. So uric acid is a proxy for both red meat and for sugar. in our society, it's actually a proxy for sugar. Now, uric acid is bad for two reasons. One, it inhibits an enzyme in your blood vessels called endothelial nitric oxide synthase, or eNOS. This is your endogenous blood pressure lowerer, keeps your blood pressure down. And so when your uric acid rises, your blood pressure rises. And it is the reason why sugar is more important for hypertension than salt is. And when you actually look at the data,
yes, thank God you're saying that.
Salt restriction, sugar restriction actually causes a bigger decline in blood pressure than salt restriction does.
Yes, thank God. I mean, I've seen this over and over, that the cause of high blood pressure is not necessarily salt, it's sugar. And when insulin resistance is driving the high blood pressure in the first place.
Indeed. And insulin also prevents you from being able to excrete sodium. So the higher your insulin, the more sodium you hold on to at the kidney, which raises your blood pressure too. So by fixing the sugar, you're fixing the insulin resistance, you're fixing the uric acid, and you're lowering your blood pressure virtually overnight.
Yeah, and that's why people who stop sugar and starch, like they just pee a lot because they lose the sodium because their insulin goes down and they start peeing a lot and lose a lot of fluid, which is water weight, but that actually is a good thing.
That's a good thing. We showed in our 43 children study that these kids' blood pressures went down by 5 points in just 10 days with no change in sodium. Okay?
Yeah, it's true. It's true.
So that's one reason why uric acid's important, is because of the blood pressure thing. But the second reason uric acid's important is because uric acid blocks an enzyme that are in your mitochondria, carnitine palmitoyl transferase 1, CPT1. This is an enzyme that regenerates the transporter carnitine. Carnitine is a transporter for fatty acids from the outside of the mitochondria to the inside of the mitochondria so that they can be burned for energy. If you poison that enzyme, you don't regenerate the carnitine. You can't transport the fat into the mitochondria. Mitochondria become dysfunctional. And guess what? You have buildup of fat in your cells because you can't burn it. So uric acid's a bad guy in the story. And sugar makes uric acid. So the problem with uric acid, just like the problem with ALT, is the interpretation. If you look at the lab slip, it says 7 is the upper limit of normal. Wrong. 5.5.
Yeah.
Anything above 5.5, you got a problem. So,
by the way, what should fasting insulin be? Because I think we didn't talk about the number there, but it's important because it's what your doctor's going to say is normal and you is normal, and not do the same thing.
Agreed. Fasting insulin should be less than 10. Optimally, if you're an exerciser and all, you might even get it less than 5. Okay, if you're
mine's less than 2.
Well, you are a paragon of virtue, Mark, because you practice what you preach.
Well, no, I just don't eat a lot of sugar and starch and exercise, and it's not that hard.
That's right. Well, mine's not as good. Mine the last time I checked was 8.6. Okay, but it's below 10. If your fasting insulin's above 15, that's a problem. Okay, to be sure. All right, so fasting insulin, ALT, uric acid. Okay, the next thing you want to check is your lipid panel. Now, the problem with your lipid panel is that everybody just looks at the LDL. The LDL is the least important thing on that lipid panel. I'm not going to say it's not important, but it's the least important. What's more important is the triglycerides, because the triglycerides are much, much more atherogenic than the LDL is.
Which is amazing, right? Because our entire medical system, a $1 trillion pharmaceutical drug, is focused on lowering LDL and not addressing triglycerides. Because, you know why? There's no drug that really works to lower triglycerides that well, except fish oil and maybe niacin, which is vitamin B3.
Right, exactly. The reason everybody focused on LDL is because we had a drug for it called statins. That's the reason. Okay, not because it was the really atherogenic particle, but rather because we had a medicine for it. Okay? Same thing we did with growth hormone. Okay. We made short stature a disease in order to be able to prescribe growth hormone so that the drug companies could make lots of money. And then, by the way, this is all in the book, in terms of how big pharma kind of games the system.
Yeah.
Okay. So, triglycerides more important than LDL, and also HDL more important as well. And the reason is because HDL, aside from being the good cholesterol, is actually the evolutionary byproduct of when LDL gets offloads its lipid. But the IDL, or the intermediate density lipoproteins, which you measure in the LDL fraction, are actually from the triglyceride. So, in other words, these are evolutionary byproducts of each other. And so you have to look at the pattern in order to figure out what actually happened to the molecules coming out of the lipid. And that's
the triglyceride HDL ratio is way more predictive than your LDL or even the total cholesterol to HDL ratio.
And that's exactly why, is because they are evolutionary products of each other. So, yeah, I agree with you. The TG to HDL ratio tells you the most. So you need to look at that lipid panel, but you don't just need to look at the number. You need to look at the ratio. You need to look at the pattern. Okay. And then finally, we get to the things that matter the least: hemoglobin A1C and fasting glucose, because those are the last things to change. Okay. By the time those change, horse is out of the barn.
Yeah.
So, yes, we do measure them, we do look at them, but that at that point, you're already mitochondrially unfit.
Yeah. And also you talk in the book about not just looking at like LDL, which is basically the weight of the cholesterol, but the quality of the cholesterol and the number of particles and the particle size as a big predictor, more important predictor. And yet, we're practicing 20th century medicine in the 21st century because most doctors don't even measure that. I mean, it's available through Quest or LabCorp. It's not hard to get.
Well, in order to do it right, you have to do what's called a VAP analysis. You have to really sort of ultracentrifuge all of them to figure out what these different things are. It costs money. It's about $500. There are companies that do it, like Atherotech. Yes, Quest does it, but the bottom line is insurance doesn't usually pay for it. Yeah. And so people tend not to order it for that reason.
But the LabCorp one is like $50, I think. The NMR from the LabCorp.
Is it?
It's not expensive. I've been doing this on everybody since it was made by Liposcience, and then Liposcience was bought by LabCorp. This was back 30 years ago, and it's been around. Ron Krauss pioneered this over 40 years ago. And it's not like a new thing, but it takes forever for stuff to get incorporated into medicine. So basically what you're saying is if people can look at their own lab tests using the guidelines you provide in your book, the things that we just talked about, through some really pretty easily accessible standard tests, you can determine whether you have metabolic syndrome and insulin resistance, which is the big cause of all these health-related concerns we're talking about.
Exactly right. So, your doctor has the capability if they have the knowledge. The problem is invariably they don't have the knowledge. So you may have to arm yourself. And that's what I try to do in the book, is try to help people understand their own bodies.
Okay, amazing. So I want to move on to another key part of the book, which was so exciting to me because as a functional medicine doctor, to see someone from an academic medical center who's been a professor and a researcher for 40 years come to the exact same conclusions that I'd come out from clinical practice was like, music to my ears. And you basically said something that I often say. So just because you know the name of the disease, you don't know what's wrong with you. And you say it in a different way, but you say, diseases like cancer, hypertension, diabetes, heart disease, they're just downstream symptoms of the real problem, right? So talk about that. And then let's get into these 8 subcellular pathologies that underlie all these metabolic diseases.
Sure. So let's take a typical example. Okay. Let's take LDL. Okay. Doctor says you have high LDL. All right. They say that's the disease. Here's the treatment for it, a statin. Garbage. Okay. Yeah. Total garbage. All right. The fact of the matter is, if you look at the statin literature, which we did and which we do, and which, is out there for everybody. Okay. 44 studies in the meta-analyses, the Cochrane group and Dubroff, et cetera. There's several of them. Bottom line, For primary prevention, if you take a statin, you will increase your lifespan by 4 days.
Yeah, but 4 days could be a lot. You can do a lot in 4 days. Right?
I suppose
Isn't it worth
so.
the trillions of dollars? It's worth $1 trillion.
I guess the question is, since 20% of people who go on statins develop diabetes, and yet another 10% have rhabdomyolysis and other problems related to the statins, is that a good trade? The bottom line is the doctor will tell you, oh, you have high LDL, here's the treatment. Garbage. Okay. The high LDL is a symptom of the problem, not the problem itself. Same for high blood glucose. So you have high blood glucose. The doctor gives you, sulfonylurea or glutamide or whatever, to lower your blood glucose, and it will lower your blood glucose. The point is the high blood glucose was actually a manifestation of the mitochondrial dysfunction. You haven't done anything for that. Yeah. And the bottom line is all of these medicines are treating the symptoms. They're basically salutary. They're not actually dealing with the problem. It's like giving an aspirin to a patient with a brain tumor because they have a headache. Might help the headache, ain't going to do a damn thing for the brain tumor. Yeah. And that's the way modern medicine has been dealing with all of these problems until you get to root cause. And Mark, I know that is like the two words that put your hair on fire as a functional medicine doctor. I got it. Those are the words. Root cause. Okay. You got to fix the problem. You don't fix the symptom of the problem. As I say in the book, you go up into your attic and you find a wasp buzzing around your attic. What are you going to do? You're going to kill the wasp, or are you going to find the wasp's nest? All right? Exactly. Where there's one wasp, there's many wasps. All right? Yeah. You got to fix the problem, not the result. You got to fix the problem, not the symptom. All right?
And you say these diseases are not druggable. That's an interesting concept. They're not druggable. You may modify the symptoms, but they continue to progress. They continue to get worse, and you continue to die from them. It might be a little slower. You might slow the rate of it. You might improve it a little bit, but they're really not fixing the problem.
Right. Well, in the case of the high blood glucose, it's not the glucose that's causing the problem. It's the insulin. The insulin's actually driving all the chronic metabolic disease, not the glucose. And I can prove that too. Okay. There's a mouse, my favorite mouse. Can we talk about mice for a minute?
Sure.
You okay? Talking about mice? Okay. My favorite mouse in the entire world. Okay. It's called the Poderco mouse, the glomerulopodocyte insulin receptor knockout mouse. Okay. So this mouse is missing.
Whatever that means, but okay.
This mouse doesn't have the insulin receptor in his kidney. Okay. It's been lifted out genetically. All right. This animal has normal blood glucoses. This animal has normal glucose tolerances. This animal has the worst diabetic kidney disease of any animal model on the planet.
Wow.
Why? Blood glucoses are normal. Everyone says, oh, it's the glucose that's causing the kidney disease. Garbage. It's the insulin that's causing the kidney disease. And we know that because the type 1 diabetics, they have high blood glucoses, but their kidneys don't get shot for 30 years. The type 2 diabetics, their kidneys are shot before they even walk in the door.
Yeah.
Because they have high insulins, because it's the insulin that's the problem, and we're not touching that.
This is really important. And I one of the things that really woke me up to this was this big study of 10,000 diabetics called the Accord study. You remember the study from a long time ago. And the idea was, let's aggressively lower blood sugar in order to improve outcomes, reduce deaths and kidney failure and all the complications of diabetes. And
it increased the deaths.
Yeah. So actually it was fascinating because the more insulin you gave, the more drugs like the oral hypoglycemics you mentioned, the sulfonylureas, they work by increasing insulin, which is like flogging a tired horse. And they produce more insulin. And the more insulin you give, the worse the outcomes. So this was just a fascinating study. Better glucose control, more deaths, and more complications.
There are actually 5 studies that have shown the same thing. Accord's one of them, but the advanced study showed it. The ADVT trials showed it. The miraglitazar study showed it. The UKPDS study showed it. The bottom line is more insulin, more death.
Yeah. And yet we continue to do the same thing in medicine over and over, despite all the research. We say we practice evidence-based medicine, but we really don't. We ignore the evidence that isn't actually fostering an increase in the sale of drugs and medical procedures. It's just all the incentives are so backwards.
Bottom line is Einstein's theory of insanity is rife within medicine, and he famously said, doing the same thing over and over again and expecting a different result. Well, we've been doing the same thing over and over again for the last 50 years. And you know what? No different result.
So you frame all these diseases as really the tip of the iceberg. And underneath it, you say are these 8 processes, these 8 metabolic phenomena, these subcellular pathologies, you call them, that are really driving everything. And I'll just list them, and then we can kind of go into them all. We talked a little about insulin resistance, but glycation, oxidative stress, mitochondrial dysfunction, we've touched on this, membrane integrity, inflammation, epigenetics, autophagy. You talk a lot about this in the book. It's a lot of big words, but it's actually a lot of the same topics that I wrote about in my book, Young Forever, because it all drives chronic disease, all drives aging. And they're underneath, these are also known as the hallmarks of aging, which are the phenomena that happen that are driving the disease. So hallmarks actually are upstream, and they're not symptoms. They're basically these phenomena that happen from different insults, mostly from food, by the way. And we'll talk about how to fix them with food. And you kind of break it down. I was just like jumping up and down when I saw it. I was like, wow, this is it. You got it. So tell us about these 8 processes and how they lead to all these diseases.
Exactly. So these 8 processes are, for the most part, not processes that you can sort of test for. They're happening in the cell. Okay. There are ways to do it. I mean, researchers can do it, but they're not, shall we say, clinically available. But they're going on. Yeah. They're going on in all of us. It is part of life. All of these are part of life. You can't stop them, but you can slow them down. But you can only slow them down with food. All right.
So they're foodable.
They're all foodable. Right. Exactly. Not druggable, all foodable. All right. Example, glycation. So glycation, a glucose binds to a protein. Now, when it does that, it makes that protein less flexible. It makes that protein end up being recycled. Okay. It might change the function of that protein. It might cause that cell to become more fragile and friable and might end up causing cell death. Okay. So glycation is not a good thing. Now, this is what diabetics measure when they measure hemoglobin A1C. This is glycated hemoglobin, the glucose binding to the hemoglobin molecule. Well, that's happening all over your body. It's happening all of the time.
Yeah.
The question is how much? Right? It is the cause of wrinkles. It is the cause of cataracts. Right?
Yeah.
The cause of cardiovascular disease inside your blood vessels. It's one of the causes of dementia, not the only one. But it's the bottom line is you don't want to be glycating. All right. Now you're going to be glycating because it is a process you can't stop. Okay. It is part of life, but you can slow it down. How do you slow it down? Stop providing the substrate. Okay. And the substrate for glycation are 2. Glucose. Yes. But fructose is 7 times worse. So both do it. But fructose does it 7 times faster and releases 100 times the number of oxygen radicals, which we'll get to in number 2. So
that's why high fructose corn syrup and everything is super bad, right? It's extra fructose.
Yeah, but there's fructose and sucrose too. I mean, so it almost doesn't matter. The point is, sugar's a bad guy in the story. Okay, full stop. That's what we don't, tell our patients, and that's the thing that they need to watch, and it's the thing that they can control themselves if they choose to. So that's number 1. Number 2, oxidative stress, those little hydrogen peroxides. Now, hydrogen peroxide is good if you have a wound, but it's not good if it's inside the cell. Right? Because those hydrogen peroxides. Unless
you want to kill an infection or cancer or something, then it can be good. But your body makes a little bit, but it shouldn't make too much.
Right. But you shouldn't be making it in your liver. Right. No. Well, every time a hydrogen peroxide gets made, okay, it's doing damage. It's doing damage to a lipid. It's doing damage to a protein. Ultimately, it will kill cells. The bottom line is oxidative stress occurs every time that glycation reaction occurs. Now, it also occurs from iron. It also occurs from various other processes that go on in the body. But the sum total of that oxidative stress is the aging reaction. That is what aging is. And so we need to basically try to mitigate it as much as possible. Now, you can't mitigate the iron, but you can mitigate the sugar. You can mitigate some of the other reactive oxygen species drivers, like, for instance, environmental toxins that are available, okay, like insecticides and things like that, that will cause it as well. All right. Number 3, mitochondrial dysfunction. Now, remember, we talked about mitochondria being sort of at the heart of this whole problem. Well, it turns out fructose, that sweet molecule in sugar, inhibits 3, count them, 3 separate enzymes that mitochondria need. We've talked about one, CPT1.
And mitochondria basically make energy from the food you're eating and the oxygen you breathe that runs everything in your body. So when that process gets up, you're having an energy crisis.
Exactly right. Exactly right. It inhibits an enzyme called AMP kinase, which is the fuel gauge on the liver cell. It inhibits an enzyme called ACAD-L, acyl-CoA dehydrogenase long chain, which is necessary to get the fatty acids oxidized. So the bottom line is, if your mitochondria are dysfunctional, you're going to be sick. And fructose is a 3-in-1 mitochondrial toxin. There are others. I mean, there's cadmium.
Well, they're a good deal. 3 for 1, right?
But bottom line, that's like number 1.
Yeah.
Number 4, okay, insulin resistance. Now, we've spent enough time on that, so I think we'll go to number 5.
Yes.
Number 5, membrane instability. Now, imagine you have a balloon. Okay, you blow up the balloon and you try to pop a hole in that balloon with your finger. Won't pop. But if you take a pin, it will pop. Okay. Now, take a balloon, blow it up, and put it in the corner of your bedroom for 3 weeks. It will slowly deflate. Okay. Now, undo the knot, and now blow up the balloon again. Now try to puncture the balloon with your finger. Now it'll puncture. What happened? How come the balloon would not puncture with your finger the first time, but it would 3 weeks later? How come? Answer, because the membrane, the balloon, changed properties. So the membranes of your cells, and especially of your neurons, have to turn over, and they have to basically maintain integrity. And the problem is that there are a lot of things that can inhibit that integrity. Again, one of them being sugar, insulin being another one, but there's a way to fix that. There's a way to treat that. Omega-3 fatty acids. Those are the things that improve membrane integrity in your liver, in your arteries, and most importantly, in your neurons. And so where did the omega-3s come from? Well, unfortunately, not farmed fish. They're omega-6s. The omega-3s are made by the algae. The wild fish eat the algae. We eat the wild fish. Well, unfortunately, wild fish is expensive and not immediately available in many parts of the country and parts of the world.
Right.
Another reason for problem. Number 6, inflammation. Now, you have talked about inflammation till the cows come home. Okay. Your PBS special is all about inflammation. I know. And I agree. I totally agree. Okay. The question is, where's the inflammation coming from? Well, it could be coming from a bunch of places. Could be, like, for instance, if you have an autoimmune disease like rheumatoid arthritis, it's coming from your immune cells and stuff. But where's the inflammation coming from in people who don't have autoimmune disease? It's coming from your gut. Okay. Your gut microbiome. So your intestine is functionally outside your body, and your intestine provides a barrier to keep the stuff in your intestine, the literal in your intestine. You might have to bleep that out, but hopefully
it's fine.
Okay. All right. The bacteria, the cytokines, the lipopolysaccharides, the stuff you do not want to get into your bloodstream. Okay.
It's a sewer in there.
It's a sewer. That's exactly right. It is a sewer in there. And the goal is to maintain the barrier so that those bad guys don't end up in your bloodstream. Now, you have two mechanisms for doing that. One is the mucin layer. Okay, so there's a mucus layer on
like
top
mucus,
of like mucus on the top of your intestinal epithelial cells. That's one. And the second is that there are proteins that guard the junctions between the cells, that where stuff could slide through. Okay, those are called tight junctions. And tight junctions, like for instance, zonulins, that's what goes wrong in celiac disease.
Yeah.
So you need the mucin layer, you need the tight junctions, you need to all be effective, all right, in order to maintain that intestinal barrier. Well, guess what? If you don't feed the bacteria in your intestine, your bacteria will choose the mucin layer to be its food. It will chew through the mucin layer, exposing all those intestinal epithelial cells to all these bad guys, and you will end up with intestinal pathologies. I just saw a paper that just came out that showed that Crohn's disease severity and incidence and severity is related to ultra-processed food consumption.
Well, for sure.
For exactly this reason. Interesting, ulcerative colitis was not, but Crohn's was. So you got to feed your bacteria, your microbiome. Those little, you got 100 trillion bacteria in your intestine. Okay, they got to eat. Well, what do they eat? They eat the fiber in your food. So you have to feed your gut. Well, unfortunately, the Western diet is fiberless food. And so they're going to eat the mucin, okay, exposing your intestine and generating inflammation. Second, you have those tight junctions. Well, those tight junctions can become dysfunctional. You can nitrate those tight junctions. And guess what nitrates those tight junctions best? Sugar.
Yeah.
A bad guy.
Yeah. I don't know if this is true, Robert, but I talked to Bruce Ames, and he said that they did research in his lab where they found that fructose, because it requires extra energy to be absorbed, meaning that it requires more ATP to be absorbed. It actually draws energy out of the gut, and you need energy to keep those tight junctions together. And the fructose actually has another effect, which is to create a leaky gut. And then you get this whole phenomena we call metabolic endotoxemia, meaning the bacteria and toxins leak out. It activates your immune system. Your immune system gets activated, and that causes insulin resistance at the cellular level. So it's like all connected.
It's all connected. Exactly right. So you need that intestinal barrier to be working, and you need to be working 24/7. And you're right. Fructose, because it has to be phosphorylated in order to get across, is depleting ATP from those intestinal epithelial cells. So again, and the paper came out just about 2 weeks ago in the journal Cell from Ivanov's group at Columbia, which showed that sugar depletes the Th17 cells, which are the barriers, and the IL-17, which is the barrier, which then allows all the fat to rush in and generate its own inflammation. So bottom line, you got to keep your gut happy. And the way to do it is to feed it. And what you have to feed it is fiber. And the problem is processed food is fiberless food. So there you go. Number 7. We're not done.
No, I know. There's two more.
Two more. Number 7, methylation. So methylation is a process that goes on normally, but you don't want to methylate things out of hand. And if you are methylating proteins, they are losing function. And you can methylate DNA, and it will also cause problems in terms of function. We know this from various genetic differences, like, for instance, the agouti mouse, and also from patients with methyl tetrahydrofolate reductase deficiency. They end up having high levels of protein of an amino acid called homocysteine. And homocysteine is a sticky amino acid that can drive cardiovascular disease. And so by increasing B1, B2, B6, B12 folate, we can keep methylation at bay. But again, processed food, not high in those things. And then finally, number 8, which is my favorite, autophagy. And autophagy is garbage night for the cell. Okay, so your cell makes junk. Okay, during the course of the day, it makes junk, and that junk can be protein aggregates or lipid epoxides, various dysfunctional mitochondria because they burn out, and so you have to recycle this stuff to get it out. So imagine you wherever you live in Massachusetts. Imagine your garbage men go out on strike. Okay, for the first week, you're okay. For the second week, maybe starting to smell. Third week, now the rats are kind of, tempted. By the fourth week, you may have some problems with your plumbing. And by the fifth week, you're going to move out of your friggin' house. All right. That's autophagy. That's garbage night. Okay. You have to recycle all the in order to make room for the new stuff. Okay.
And that's a key part of longevity, is to activate autophagy, right?
Absolutely. Autophagy and longevity are, part and parcel of the same thing. And we're actually very interested in that. We're studying a specific supplement that might improve autophagy and therefore improve longevity. Amazing. So that's near and dear to home.
So now, Robert, you've talked about all these 8 processes, and the key to fixing them is what?
The key to fixing virtually all of them is food. Okay. Now, glycation, fructose and glucose, oxidative stress, fructose, glucose, various fatty acids like trans fats, mitochondrial dysfunction, again, fructose, cadmium, other insecticides, insulin resistance, fructose, glucose, branched chain amino acids, membrane integrity, omega-3s, inflammation, fiber, methylation, vitamins B1, B2, B6, B12, folate, and finally autophagy, intermittent fasting, and also keeping your insulin down. So bottom line, all 8 fixable by food. So then the question is, what about exercise? Turns out exercise is very good for you. I'm for exercise. I mean, you're for exercise too. Exercise is excellent. Okay. Exercise is the second best thing you can do for yourself after diet. All right. But when you actually look at those 8, exercise only helps you with 4 of them.
Yeah.
So you cannot outrun a bad diet.
No, I say that a lot. Yeah, exactly. That's amazing. So basically in your book, you go into great detail about how to understand whether you have these processes going on, how to fix them, because these are all the things that are underlying all the diseases that we get, and we're just treating the symptoms and not the disease. So this is really powerful, and it's really in line with functional medicine. I want to talk about something you also talked about in the book, which is 4 specific things in our food supply that damage mitochondria and what they have in common and what do we do about it. And we've touched on them a little bit, but can you just kind of break it down for us? Because you basically keep saying that mitochondria are key to longevity, to health, to preventing insulin resistance, and that people who have insulin resistance, by definition, have dysfunctional mitochondria. So what are those things that damage them, and what do they have in common, and what do we do about it?
Okay. So number 1, fructose. Number 2, trans fats. Number 3, alcohol. Number 4, branched chain amino acids. Now, branched chain amino acids are a little harder.
I was surprised by that. I want to hear about that.
Right. Leucine, isoleucine, valine. Okay. Now, these are 3 essential amino acids. You have to consume them. Your body does not make them. They are very important for muscle. 20% of muscle is branched chain amino acids. This is why bodybuilders, consume protein powder. They put, a big scoop of protein powder in their smoothies, okay, to provide them with extra branched chain amino acids. And if you're building muscle, that's an okay thing to do. However, what if you're not building muscle? What if you're like a mere mortal like me, okay, and you're consuming extra branched chain amino acids? And we'll talk about where they come from in a minute, okay? What's happening is you're not able to lay down more muscle because you need the exercise to do that. So those extra branched chain amino acids are going to your liver. The liver is going to turn them into energy. The liver deamidates them. It takes the amino group off. And now they've become, instead of branched chain amino acids, now they're branched chain organic acids. And then they go into the Krebs cycle, the tricarboxylic acid cycle. They overwhelm the Krebs cycle, just like fructose did, just like alcohol did. And they end up making liver fat. And that liver fat ends up causing insulin resistance also.
Don't branched chain amino acids help with muscle synthesis and building muscle? And
if you're building muscle. If you're building muscle. But if you're not, then no. So that's the point, is that the exercise is the cofactor there that is required.
So take them after you exercise, basically.
Yeah, and that's fine, but only after you exercise. Now, the question is, where is the mere mortal like me getting his branched chain amino acids from? And the answer is corn-fed beef, chicken, or fish, because corn is very, very high in branched chain amino acids.
So if you're having regenerative meat or you're having wild meat, you're not seeing that?
That's right. That is, shall we say, healthier amino acid profile.
Yeah, trans fats are pretty bad, and they're still on the marketplace, which is shocking to me because in 2015, 7 years ago, the government said they weren't safe to eat. And they're still out there. It's amazing. I don't know how the drug companies, the food drug, I should call them drug, but the food and drug is the same. These bad foods are really like poison medicines for the body, but they are still in the food supply. So to be very diligent about it.
Listen, once upon a time, the Food and Drug Administration in 1958 codified 170 items in food as being safe. Okay, that was the beginning of what we call the GRAS list, generally recognized as safe. 170 items. Okay, 1958. Okay, it is now what? 63 years later. How many items are on that list now? 10,000.
Too many.
10,000. You really think there are 10,000 things you can put in your body that won't make you sick? Really?
No.
This is insane. Okay, and in fact, the Food and Drug Administration privatized that list. They basically farmed it out to the food companies to decide what should be on that list. So basically, any food company can put any damn thing they want and say it's okay. And that is just not true.
No. Well, this is amazing. So, Robert, this book, Metabolical, is so fantastic. Everybody needs to read it. You can get anywhere you get books. I just want to, there's so much in there we didn't get to talk about, such as, how we think about these nutrient sensing systems and kinases, and it gets a little technical, but the book explains it all beautifully, really accessible. But I want to close by talking about how to fix the food system, because what you're saying is essentially is that we're living in a swamp of toxic foods that make us sick, that cause disease and kill us prematurely. And that it's 100% preventable, and that the costs associated with it, the suffering with it is preventable, but that it's not something that we alone can solve, that we have to look to the government. And people are skeptical of the government, but
drain
I think,
the swamp. Drain the swamp.
No, we're drain the swamp. But honestly, we have to. And I started a nonprofit to help work on food policy. I know you're working on it. So in your book, you also talk about what the USDA, the Department of Agriculture, the FDA, and Congress can do, and what they can do to help us, and maybe why they're not doing it, and how do we really create real change in the food system. So maybe we got another 10 minutes left. Why don't you wrap up with that? Because I think that's a really important piece of the conversation.
Absolutely. So bottom line is the FDA is not doing anything. That's what it comes down to. The FDA really has become more of the FMA, the Federal Medicines Association, than they are the Food and Drug Administration. They've really abdicated, food to the food companies. And I think that has been a, terrible disservice to us and to the country in general. Now, why did they do that? Well, the reason is because $56 billion a year in tariffs on processed food when we sell our food abroad to the federal government. In other words, this is part of, their money stream. This is part of, this is, basically sucking on the teat of the food industry. And so the government makes its own money. That's one reason. Now, the second reason, which I think is a bigger problem, is food subsidies. Now, not everybody believes this, but I think that food subsidies are sort of the reason why we have this problem in the first place and why it's been driven. All right. We subsidize corn, wheat, soy, sugar. In fact, we've been subsidizing sugar since the inception of the Union in 1790. It is the second oldest piece of legislation on the books in, post-Constitution. Okay, 1790, we have been subsidizing sugar. Okay, we've also been taxing it. We do both, which makes even less sense. All right. Point is, the food industry can sell its processed food for cheaper because of subsidized food, because they're basically getting a kickback. They're getting a rebate for using those corn, wheat, soy, sugar. All right. Well, all of those are the bad guys. Okay, the corn is the branched chain amino acids. The soy is the omega-3s. Okay, the wheat
omega-6s. Omega-6s, you mean?
Omega-6s. My mistake. You're right. Omega-6s. I misspoke. The wheat is the gluten, which is pro-inflammatory, and of course the insulin secretion that we talked about, and then finally sugar, which I've beaten this dead horse
for a long time.
But it's a horse that needs to be beaten because it keeps, rising from the ashes. So bottom line, we are subsidizing all the things that are killing us. And we have all along. And we have since 1933, the original Farm Bill. Now, the very first Farm Bill came out in 1933, and the impetus for that 1933 Farm Bill was the Depression and the Dust Bowl of 1932.
Yeah.
Right? And we had a destitute population in the American Southwest that were dying, okay, because there was no food. And the problem was that if you took the food, which was being grown in the Midwest and the Northeast, and you put it on railroad cars and you shipped it to the Southwest, by the time it got there, it would be rancid. So the way to stop it from being rancid was to defibratize it, to basically strip the fiber off, to process it, to basically pack it into big 10-pound bags of flour, okay, and then ship it on the railroad cars and bake it up, locally. And you know what? That worked. That worked. And we saved an entire destitute population. And then came World War II, and we needed it even more because we needed to feed the soldiers in the field. And so that was okay. And then came 1946. All right. And the war was over, and the Depression was over, and the Dust Bowl was over. And we should have gone back to square one. We should have gone back to previous. But hey, people figured out, hey, I can make money at this.
Yeah.
Okay. And so instead of taking away a policy that didn't work anymore, had no need to be anymore, we doubled down. Okay. And we doubled down again, and we doubled down again. And then in 1971, okay, Richard Nixon said, food prices are still fluctuating. We need to make food cheap. Okay. And so he told his agriculture secretary, Earl Butz, to basically make food cheap. So he went to the heartland, to Nebraska, to Kansas, to Iowa, and he said three things. He said, row to row, furrow to furrow, get bigger, get out.
Yeah. Go big or go home.
That started monoculture. And that's why all of the corn is in Iowa and all the cattle are in Kansas. Okay. It's because of Earl Butz. All right. Well, that did lower the price of food. But unfortunately, what it also did was it now made the food less nutritious because now instead of the soil being rotated and being able to regenerate the soil microbiome, which is actually the bacteria and the fungi that are actually in the soil that actually feed the plant and make the plant healthy and nutritious. Okay, now it's dirt, it's dead. And so what they had to do is they had to spray it with nitrogen fertilizer to grow anything. And all of that, all the, the green peppers and the radishes and everything else, they basically don't have any nutrients in them. The tomatoes have nothing in them. All right. So we're eating all of this nutritionally depleted food because we're growing our produce in dirt instead of in soil like it was supposed to be. And all of that was to basically continue to make food cheaper. So now we have the cheapest food in the world. Okay. And we are paying
not
for
really.
we
pay. Yeah, right. Exactly. You pay, you don't pay now, you pay later. And medical bills and drugs.
You can pay me now or you can pay me later. But hey, if I'm paying you later, you know what? Then that's some other administration's problem.
Pass the buck. Yeah. Amazing. So how do we fix this? How do we change those policies? I'm curious because I'm deep in this policy world and I'm curious for your perspective. You got 4 minutes.
Okay. Until we get rid of subsidies, nothing good can happen, period.
So crop insurance is what you're talking about.
Yeah, well, that's one thing to do is crop insurance. But the bottom line is there's no reason for subsidizing food. There's no economist on the planet who believes in food subsidies because they distort the market. Let the market work. And the Giannini Foundation at UC Berkeley actually did this exercise several years ago. They modeled what would the price of food look like if we got rid of all food subsidies. And guess what? It wouldn't change except for two items, corn and sugar, which is what we need to change. So to me, that's where you start, is the food subsidies. Now, after you do that, then all hell breaks loose and, other things are possible. But ultimately, we need this thing called regenerative farming, and we need it for climate change. Because if you keep spraying nitrogen fertilizer, all you're doing is making nitrous oxide, which is the worst greenhouse gas of the bunch. Everybody's mad at methane. Okay. And the reason is because
300
methane
times
is
more
by
potent.
Cows. But the bottom line is the nitrous oxide is way worse than the methane. It's more heat trapping capacity, it has longer residence time, and it is higher in terms of the amount in the atmosphere. So as long as we keep thinking that we can just grow in dirt, we're going to keep having this problem. Now, can we fix that? Yes, we can fix that. But what we need to do then is we need to be able to access bigger plots of land and have them grow green vegetables. And that can be done very easily. You take a big pole, a 500-foot pole, you stick it in the center of a field, you put a white sheet over the edge, and you tent it on the edges, and you can grow green vegetables underneath it, even in Maine, even in Michigan, even in, Minnesota. You can actually, we can increase the crop yield in this country like that, okay, for almost no money, okay? But the point is we have to want to do that. We have to direct the federal government to, support those kinds of programs, but they're not.
Well, I'm optimistic. Yesterday, I just came back from giving a talk. It was a talk at Rodale Institute, which is kind of the original organic farming, regenerative farming research institute, where they're literally studying the difference between soil and dirt and organic or conventional farming. And it was a conference of doctors. And it was really inspiring to sort of hear that they're actually, things are changing. They just, part of the work we did with Food Fix was we got David Scott to come, who's the chairman of the Ag Committee in the House, to Rodale Institute. He got awakened to these ideas. They just testified a few weeks ago. They got $25 million as a start to help incentivize BIPOC farmers and areas where the soil is bad to actually regenerate soil. It was very, very exciting. So I think in the IRA bill, you can argue whether it's good or bad, but there was $20 billion that was allocated for some of these changes in farming practices. So I think we're moving along the right direction. It's not fast enough for either of us, obviously, but I think I'm a bit hopeful than I was a few years ago. So Robert, your work has just been so inspiring. It's been great to call you a friend and co-conspirator and good troublemaker along the path. And keep doing your work. I think everybody who is listening should get the book Metabolical, The Lore and Lies of Processed Food, Nutrition, and Modern Medicine. It really will help you not only understand what's going on in your own body, but how you can really make real change in the world. So I just honor you and thank you for being on the podcast. And any last words or thoughts?
Yeah, I mean, basically, we need all of us. This is a problem that's not going away. And it's also a problem that's going to outlive both you and me. And ultimately, no one's going to remember you or me. And the only way we're going to fix this is by banding together and speaking with one voice.
Thank you.
This is, as they say, this is a big nut. And we all have to be on top of this.
Well, thanks for being such a leader in it, really. And everybody can learn more going to his website, Robert's website, robertlustig.com, or the Metabolical website, metabolical.com, where there's over 1,000 references that he couldn't fit in his book because it would have made it 70 pages more. You can watch his video on sugar that's had 11 million views. But for sure, check it out. And if you love this podcast, share it with your friends and family on social media. Maybe you can share comments about how you have addressed your metabolic disease and what's worked for you and how you've discovered how to get healthy or the challenges maybe you've had and struggled with. And subscribe wherever you get your podcasts. And we'll see you next week on The Doctor's Pharmacy.
If you love that last video, you're going to love the next one. Check it out here.
If you go to your doctor and complain of this, they'll just pat you on the back and say, welcome to old age, or that's just part of the normal aging process. I don't think it is. I mean, maybe to some extent, but what happens when we age is we're less likely to absorb a lot of the nutrients